In this lecture, we'll talk about the random variable, and in particularly, we'll talk about the discrete random variable. This is an introduction, so we will focus on how to think about random variables and give some examples. We will not discuss the actual definition of a random variable in this lecture. If you are new to probability theory, then a very useful way of thinking about a random variable is as a variable that randomly takes one value from a given set of possible values. Random variables are typically denoted by capital letters such as x, while ordinary variables are typically denoted by lowercase such as x. So to be able to talk about the random variable, I have to identify the possible values. Let's say that this set of possible values is given by this set containing the numbers 1, 2, and 3. We use standard set notation where we put the elements inside curly brackets. The random variable will then pick up one of these three values, but which value it will pick up is unknown to us. We often use the terminology performing an experiment, and we say that the experiment leads to the random variable picking up one of the numbers. Using this terminology, before the experiment, then it's unknown which value it will pick up, but after the experiment, it will have picked up one of these values, and it's known to us which one it picked. You may also think of a random variable as an extension of the mathematical concepts constant and variable. A useful way of thinking about a variable in mathematics is as a box. The label of this box is the name of our variable, say x, and this box will contain a number. So I may, for example, put the number 6 inside the box. The whole point, of course, with the variable is that we can vary this number. I can, for example, replace this number 6 in the box with something else, say 14. So whenever we do something like x plus 1, we mean the content of the box x plus 1, that is 14 plus 1, which is 15. A constant, on the other hand, can also be represented by a box. But in this case, we typically think about the number inside the box as being fixed within the specific context. While small x is the most common symbol for a variable, small c is the most common symbol for a constant. So if I put the number 6 inside this constant box, I expect to find 6 whenever I look in the box. A random variable is sort of like a box with an LCD at the bottom. In this case, I use capital X to label my random variable. And in this case, when I look inside the capital X box, the LCD will randomly pick a number to display, which means that I have no idea what number I will see when I look inside this box. So we think about the concept before the experiment as before we look in the box. And we think of the concept after the experiment as what number did the LCD display when we looked inside the box. Once we have looked inside the box, we can take the number that we see and put it into a variable box that we typically then call small x again. So in this case, we put a 2 in the variable box. And this is standard notation. If my random variable is denoted by capital Y, then I typically denote the value that I observed when I look inside the box by lowercase y. The next time we look inside the capital X box, we'll see a different number, and then we have to create a new variable box if we want to save that number. The other important part of a random variable is that it's always associated with a set of possible values. And we typically denote this set as the range of the random variable. Whenever you look inside the random variable box, you can only see a number which is in the range of the random variable. You'll never see a number outside the range. Perhaps the most common example of a random variable is when you toss a dice and you let x be equal to the number showing on the upper surface. If it's a regular dice, then the range of the random variable is 1 through 6. In this case, you can think of the random variable as putting a dice in the box, shake the box and look inside the box, and you'll see a number. Capital X then denotes the entire box of the dice, while small x denotes what we observe when we look in the box. So if you observe a 4, you would never write x equal to 4. Instead, you should write small x equal to 4. Here's another example. If you flip a coin and you translate heads and tails into numbers, then you also have a random variable. Makes no difference to what numbers you translate heads and tails, but you do have to make the translation because the outcome of a random variable must be a number and not something like heads and tails. A slightly more interesting example. Let's say you flip a coin 5 times and your random variable x is defined to be the number of tails. That's a well-defined random variable with range 0 through 5. All the random variables discussed so far are examples of discrete random variables. By a discrete random variable, we typically mean a random variable whose range is finite. The range contains a fixed number of possible outcomes, such as 6 or 2 or a million if you like. So most of the discrete random variables do have a finite range, but it must be mentioned that there are discrete random variables whose range is infinite, but it must then be countably infinite. If you don't know what countably infinite means, I wouldn't worry too much about it at this point.